Hello and welcome back. Today we'll go over the sum and difference formulas. This is section 7.5. So I like to derive these when I can. Helps to sort of see where the formulas come from. If you just sort of accept something as a given fact to memorize, it gets stored generally in your short-term memory. If you figure out how it's formed, it gets stored in long-term. So we'll consider this first angle alpha, making the ordered pair here cosine alpha, sine alpha. And we'll make a second angle there. This is angle B, beta, making this location cosine beta, sine beta. And if we stay on the unit circle, we want to find this distance. So the distance, d squared, cosine alpha minus cosine beta squared plus sine alpha minus sine beta squared. So then d would just be the square root of that. So next, we're going to, again, we're assuming we're on the unit circle here, and we're going to rotate this so that the initial angle is on the x-axis. Since we're on the unit circle, that's happening at 1, 0. If the original alpha was here, we're then basically rotating it by beta degrees. So if we take this triangle and spin it, the new angle that will form is alpha minus beta. So cosine of alpha minus beta, sine of alpha minus beta. But this distance should be the same as this distance. Assuming we kept the triangle rigid, we rotated it until we hit the x-axis. So this distance, I'll go ahead and jump in with the square root there. Cosine of alpha minus beta minus our other x value is a 1 squared plus sine of alpha minus beta minus 0 squared. Now, since the distance didn't change, these two are then equal to one another. So cosine of a minus b minus 1 quantity squared plus sine squared of alpha minus bravo has to have the same value then as cosine alpha minus cosine bravo quantity squared plus sine alpha minus sine bravo quantity squared. So notice I've gotten rid of the square roots and just said, okay, let's look at the arguments of the square root. We know both were already under a square root. So we can go ahead and FOIL some of these out. So we have cosine squared of a minus b minus 2 cosine of a minus b, alpha minus beta, plus 1, plus sine squared of alpha minus bravo is worth, then we do the same thing here, FOIL these guys out, cosine squared alpha minus 2 cosine alpha cosine beta plus cosine squared beta. These are, as you can see, a little bit on the long side. This is a cosine squared out in front here. I still have to expand this out, so we'll go ahead and use the line directly below. So plus sine squared alpha minus 2 sine alpha sine beta plus sine squared beta. So we have a little bit of simplifying we can do. So cosine squared plus sine squared is a 1. We have another 1 here, so we have 2 minus 2 cosine of alpha minus beta. It's worth, here's a 1, here's a 1, 2 minus 2 cosine alpha cosine beta minus 2 sine alpha sine beta. Divide both sides through by 2. We can also cancel these 2's, so cosine of alpha minus beta is worth cosine alpha cosine beta plus sine alpha sine beta. Now we can also get a sum formula out of that by just replacing the minus beta with a plus beta, which will flip the signs on these two betas. So cosine of alpha plus beta, cosine alpha cosine opposite of beta plus sine alpha sine opposite of beta. If we flip a cosine and turn the angle down instead of up, the x value stays the same. So cosine opposite of beta is the same as cosine beta, but the y values will flip depending on if we spin up or spin down. So we can bring that minus out and we can say cosine of alpha plus beta is cosine alpha cosine beta minus sine alpha sine beta. So that's one of our other known formulas. And again, I like to see where it comes from. That's part of, as you're moving up in your math classes, not just seeing what happens, but why things work the way they work. Why does it work? So for example, they might ask us to use this information to find the cosine of 105 degrees. Well, we can notice that that's cosine of 60 degrees plus cosine, or I'm sorry, plus, not cosine, 60 degrees plus 45 degrees. So this is our cosine A plus cosine B. So then this is cosine 60 degrees, cosine 45 degrees, and we just flip that sign in the middle, sine 60 degrees, sine 45 degrees. So cosine 60 degrees, and that is our 1/2. Cosine 45 degrees, root 2 over 2. Sine 60 degrees, root 3 over 2. Sine 45 degrees, root 2 over 2. So then this would be root 2 over 4 minus root 6 over 4. Your author has a tendency to factor a 1/4 from that. It can be done. It's not strictly speaking necessary. All right, so next up we go with cosine of pi over 12. So that's cosine of 4 pi over 12 minus 3 pi over 12. So 4 pi over 12 is pi over 3. So cosine of pi over 3 minus pi over 4. So 3 pi over 12 is pi over 4. So here's, this time we have the minus, so we'll have a plus in the middle. So then this is cosine pi over 3 cosine pi over 4 plus sine of pi over 3 sine of pi over 4. So cosine of pi over 3, that is 60 degrees, so that we're at 1/2. Cosine pi over 4, of course, root 2 over 2. Sine of pi over 3, though, that is root 3 over 2. And sine of pi over 4, root 2 over 2. So we have root 2 over 4 plus root 6 over 4. So same absolute values appearing, just a different sign in between them. All right, so our next one introduces us to a nice handy new tool. So cosine of pi over 2 minus theta, cosine pi over 2, cosine theta. This is a minus, so we'll flip it to a plus. Sine pi over 2, sine theta. So cosine of pi over 2 minus theta. We can do a little simplifying there. Cosine of pi over 2 is 0. That term drops out. Sine of pi over 2 is just 1. 1 times sine theta is sine theta. So there's a nice little relationship between cosine and sine. We'll put a little star there since I'm going to make reference to that a bit later on. If we look for sine of pi over 2 minus theta, we can just use star to say that that's equal to cosine of pi over 2 minus pi over 2 minus theta. So just replacing theta with pi minus theta on both sides, and then we can use our just distributive property here and say that this is sine of pi over 2 minus theta is worth cosine of theta. So the pi over 2's drop out, minus opposite of theta is theta. So pi over 2 minus theta will get you from either a cosine to a sine or vice versa. We'll put a little 2 stars by that so we can reference him. So then sine of alpha plus beta is cosine of pi over 2 minus alpha plus beta. And then we do a little bit of shuffling around. We'll distribute this and regroup it. So we'll make this cosine of pi over 2 minus alpha, group that stuff together, and then having distributed this, we do still have a minus beta then. So then we just use our previous to expand that. So that's cosine of pi over 2 minus alpha cosine beta. We had a minus, so it'll flip it to a plus. So sine of pi over 2 minus alpha sine beta. So if it's cosine of pi over 2 minus alpha, that means it's sine alpha. Sine of pi over 2 minus theta, or minus alpha in this case, is then cosine alpha. So that's one of our other identities then. If we want to switch it to a minus, we do the same thing we did with the cosine. So sine of a minus b, sine alpha cosine opposite of beta, plus cosine alpha sine of opposite of beta. So sine of alpha minus beta. Cosine of opposite of beta is the same as cosine beta. So remember, the x value doesn't change whether you flip up or down from the x-axis. So we have sine alpha cosine beta. However, the sine, the y value does flip, so minus cosine alpha sine beta. So basically, sine and cosine, one of each. Sine, cosine, flip them around of which one got which. Plus stays a plus, minus stays a minus. So then we have enough to figure out any of our other functions as well. So for example, if they ask us for the cotangent of 7 pi over 12 and exact value, we know they're not asking us to do a rough calculator approximation. We can do it as a sum or a difference. So we can either do 10 pi over 12 minus 3 pi over 12, or we can do 3 pi over 12 plus 4 pi over 12. Arbitrarily, I'll work this through as a sum. Either one will get you to the same answer. So we'll do the cotangent of 3 pi over 12 plus 4 pi over 12. On your own, I would recommend trying it just to test things out. Cotangent of 10 pi over 12 minus 3 pi over 12. So that one, try on your own. So cotangent, remember, is cosine over sine. So we have cosine of 3 pi over 12 plus 4 pi over 12 over sine of 3 pi over 12 plus 4 pi over 12. So now we have the cosine of a sum. So I'll put my cosines together. I'll simplify 3 pi over 12 into pi over 4. Cosine of 4 pi over 12 turns into pi over 3. And we flip the sign for cosine. So then minus sine of pi over 4, sine of pi over 3, all over sine of. So now we have the sum of the sines. So one of each. So sine of 3 pi over 12, or pi over 4, sine of pi over 4, cosine of pi over 3, and it started a plus, it'll stay a plus. So then sine of pi over 3, cosine of pi over 4. So they just traded which one had which angle. So cosine of pi over 4, root 2 over 2. Cosine of pi over 3, that's 60 degrees, so 1/2. Sine of pi over 4, root 2 over 2. And sine of 60 degrees is root 3 over 2. And all of that's parked over sine of pi over 4, root 2 over 2. Cosine of pi over 3, 1/2. Sine of pi over 3. So the sine of pi over 3, that's our root 3 over 2. And cosine of pi over 4, root 2 over 2. So we can multiply top and bottom by 4 and basically be rid of all these over 2's. So root 2 minus root 6 over root 2 plus root 6, and then just rationalize the denominator. So we'll multiply by root 2 minus root 6, top and bottom. So foiling the top, we've got 2 minus 2 root 12 plus 6 over 2. Minus root 12 and plus root 12 will drop, and then minus 6 So I have 8 minus 2 root 4 root 3 over negative 4. So I'll factor a 2 there, 2 by, or we'll factor, my apologies, we'll factor 4. So we have 8 minus 4 root 3 over negative 4. Factor a 4, 2 minus root 3 over negative 4. So that will turn into negative 2 plus root 3. So you should come up with that same thing if you try cotangent of 10 pi over 12 minus 3 pi over 12. Okay, so next one, we are given some information. Cosine of alpha is 1/2, and we're on negative pi over 2 to 0. And that sine of beta is 1/3, and we're given that 0 is less than beta, which is less than pi over 2. So this one, just a couple quick sketches will help us along to find the exact value of sine of alpha minus beta. So our first one, we're told that we're between negative pi over 2 and 0. So in other words, we're in Q3, and that our cosine is 1/2. So here is our alpha angle, and our hypotenuse then is 2. Our x value is 1. So then our y value we know is going to be a negative. So 1 squared plus absolute of y squared is 2 squared. So absolute of y squared is worth 4 minus 1, 3. So y is plus or minus root 3. Since we're down here in Q3, y is minus root 3. So that's for our alpha. For our beta, we're on the 0 to pi over 2 angle, so we're in quadrant 1. And our sine is 1 over 3, so we have a radius of 3, a y value of 1, and our x we know is positive. So x squared plus 1 squared is 3 squared. So x squared is 8. So x is plus or minus root 8. So x is equal to, we know it's the plus that we want, and 8 is 2 root 2. So x is 2 root 2. So then sine of alpha minus beta, sine alpha cosine beta, keep the minus, and then sine of beta cosine alpha. So then sine of alpha, I'll go to my alpha drawing, and then my sine would be negative root 3 over 2. So sine opposite over hypotenuse. Cosine of beta. So beta cosine is our x over the radius. So times 2 root 2 over 3 minus sine of beta. Sine is the y over the hypotenuse there, so 1/3. We were given that value. Cosine of alpha, so x over hypotenuse, that's our 1/2. So this is, let's see, we can do a little bit of canceling here. Drop those 2's, so negative root 6 over 3. I should have kept them. Yeah, that's fine. Minus 1/6, that's simplified enough. So your author may or may not put those together. 2 terms is fine for that. So then we will work on establishing an identity. So sine of alpha plus beta over cosine alpha cosine beta. We're going to prove that this is equal to tangent of alpha plus tangent of beta. So we'll just use the left-hand side and we'll expand. So sine alpha plus sine beta is sine alpha cosine beta plus sine beta cosine alpha over cosine alpha cosine beta. Now, because we have two terms that have a common denominator, we have the right to split that up and just keep that common denominator. So it's sine alpha cosine beta over our common denominator cosine alpha cosine beta plus our second numerator sine of beta cosine of alpha over our same denominator. Cosine betas drop, cosine alphas drop. Sine alpha over cosine alpha is tangent alpha. Sine beta over cosine beta, tangent beta. It's a nice pretty little identity there. They not too terrible proof, excuse me. So the tangent of alpha plus beta, sine of alpha plus beta over cosine of alpha plus beta. Well, we can expand each of those. So we have sine alpha cosine beta, keep the plus, and sine beta cosine alpha. We can expand that denominator as well. So cosine A, cosine B, flip the sign, sine A, sine B. So this next part we use a little mathematical sleight of hand. And we're going to multiply top and bottom by 1 over cosine alpha cosine beta. So when I distribute that, cosine beta drops from that first term and I have sine alpha over cosine alpha. Distributing the second term, the cosine alpha drops and I have sine beta over cosine beta. Do the same thing down here. Cosine alphas drop on the first one. Cosine beta over cosine beta is a 1. Hang on to our sine. Sine alpha over cosine alpha is tangent alpha. Sine beta over cosine beta, tangent beta. So this is equal to tangent of alpha plus tangent of beta over 1 minus tangent alpha, tangent beta. Now, if we wanted tangent of alpha minus beta, we just have to remember that we flip the sign then on the beta. So tangent alpha plus tangent opposite of beta over 1 minus tangent alpha, tangent minus beta. Tangent minus beta is minus tangent of beta. So remember, tangent is sine over cosine. If sine flips and cosine doesn't, it'll flip the tangent. So tangent alpha minus tangent beta over 1, now plus, because of that same property, tangent alpha, tangent beta. All right. So we'll take a look at finding an exact value. So we'll try the cosine of arctangent of 5/12 minus arcsine of -3/5. We're going to let alpha equal arctangent of 5/12. Remember, arctangent, you can write it this way or that way. I don't care which way you write it. Let beta equal arcsine of -3/5. So then tangent of alpha is 5/12. Tangent of beta, sine of beta, my apologies there, getting ahead of myself. Sine of beta is -3/5. So we'll draw our quick triangles here. Here's our alpha triangle. So our y value 5, x value of 12. And you hopefully recognize that as a 5, 12, 13 triangle. Otherwise, just do 5 squared plus 12 squared equals r squared. So r squared, 25 and 144, 169. R is 13. So then the cosine of alpha would be 12/13, and the sine of alpha would be 5/13. Looking at our beta here, the sign is negative, which means since we're working with sine, we're on the negative pi over 2 to pi over 2, so we're down here in Q4. So we have a radius on our circle of 5, and our y value is -3. So 9 plus x squared is 25. So x squared, 16. X equals plus or minus 4. We're in Q1 though, so x equals 4. So we already have sine of beta. Cosine of beta then would be 4/5. So then we have basically cosine of alpha minus beta, since we named this guy alpha and this guy beta. So that's cosine alpha, cosine beta. Flip the sign, sine alpha, sine beta. And then we just finish it off with substitution. So cosine alpha was 12/13. Cosine beta was 4/5. Sine alpha was 5/13. Sine beta was given as -3/5. Yeah, 48/65 minus 15/65. So this is worth 33/65. So we have one more nice linear one that we can make easier by doing a little bit of squaring. So we're going to solve root 3 sine theta plus cosine theta is worth 1. So one option we have now, since we have some more tools available, root 3 sine theta plus cosine theta squared is 1 squared. So foiling this out, we have 3 sine squared theta plus 2 root 3 sine theta cosine theta. If it helps you to write it out twice before you FOIL it, that's absolutely fine. Write it out twice then. Plus cosine squared theta is worth 1. 1 squared is still just 1. So let's see. So we have 3 sine squared theta plus cosine squared theta. Cosine squared theta I can turn into 1 minus sine squared theta. So 3 sine squared theta plus 2 root 3 sine theta cosine theta plus 1 minus sine squared theta is 1. So just sine squared plus cosine squared is 1. We can put these two guys together then and call this 2 sine squared theta plus 2 root 3 sine theta cosine theta. And let's see, we have a 1 on either side, so we can just subtract 1 on both sides and say it's equal to 0. What we can then do is a little bit of factoring of this. We can definitely divide both sides through by 2. That might make it easier as well. And then we'll factor a sine. So sine theta by sine theta plus root 3 cosine theta is equal to 0. So we divided both sides by 2. That's why those are gone. We factored a sine from each one of these then. We have a multiplication problem ending in 0, so either sine theta is 0 or root 3 cosine theta is 0. Sine theta plus root 3 cosine theta is 0. So sine theta equals 0. If we're talking 0 to 2 pi, then theta is 0 or pi. So this other one, then, we can say that sine theta is negative root 3 cosine theta. So basically we want to have either the case of 1/2 negative root 3 over 2 or negative 1/2 root 3 over 2. That way, if you take your cosine, multiply it by negative root 3, you get your sine. So where those points are, 1/2 negative root 3 over 2, that's at our, excuse me, we have 5 pi over 3 or 2 pi over 3. Now, one thing to watch out for, though, since we did square both sides, we could have extraneous solutions. Check for extraneous solutions. Extraneous solutions, you're always checking in the original. So I'll leave it up to you to do that check, but again, plug each of these 4 in there. I'll tell you which ones we'll end up keeping, but I'll let you actually do the work on how we came to this conclusion that we only get to keep 0 and 2 pi over 3. So again, I'll have you check each of those 4. 2 of them we keep, 2 of them won't work in the original. So in 7.5, you're going to try out 13 to 97, every other odd, every 4th problem, or the equivalent in my math lab. All right, thank you. See you next time.